Good morning, everybody. Welcome to Tippett's Physics. What is crappinin'? Today we're going to do a practice problem of throwing an object off of a building. So let's read the problem. A pumpkin is thrown 10 meters per second out of a building that is 10 meters high. When we analyze these problems, we have to be able to separate horizontal and vertical motion first. So let's draw a picture, and then we'll go through the process of solving this. We've got our Albert Einstein pumpkin. He's thrown out the window horizontally at 10 meters per second. So we'll call this Vx is 10 meters per second. And eventually he's going to follow this path and hit the ground. So let's look at our vertical aspect. When you throw something horizontally, technically this pumpkin is falling straight down. So the initial velocity in the y direction is 0 meters per second. We know the building is 10 meters high. Since it's falling below here at the top, we're going to call it negative 10. So negative 100, meters. And we know the acceleration due to gravity is negative 9.81 meters per second squared. Okay. So in the vertical direction, we know VI, D, and A. We want to find the time first. So what we'll do is look at our reference table. And what formula has D, VI, T, and A? And that would be this one right here. D equals VIT plus 1/2 AT squared. So to find the time, the formula is D equals VIT plus 1/2 AT squared. We want to get T by itself. VI is 0, so VI times T is 0. When we get T all by itself, T is the square root of 2D over A. We'll plug and chug. So T is the square root 2 times negative 100 meters over negative 9.81 meters per second squared. Plug that sucker in our calculator, and we get the time is equal to 4.5 seconds. Okay, so when we throw something horizontally, it takes 4.5 seconds to fall down. It's also going to take 4.5 seconds in this direction to hit the ground. So let's look at what we know horizontally to find how far the ball went. So horizontally. They tell us we threw it at a velocity of 10 meters per second. Remember, in the horizontal direction, when we neglect air resistance, the velocity is constant, so it never changes. And the time we just found is 4.5 seconds. And to figure out how far it went, the distance, let's go back to our reference table. There's only one formula for constant velocity, and that's velocity is distance over time. So we'll say Vx is equal to dx over time. The x's just mean that it's in the horizontal plane. Get d by itself, so distance in the x direction is velocity times time. Distance is 10 meters per second times 4.5 seconds. And that gives us 45 meters. And that's how you solve projectiles that are thrown horizontally off a cliff. Hope that was helpful. See ya.